Welcome to this 10-minute journey into a cutting-edge science topic. Just today I saw an article saying how scientists had created 100 litres of diesel a day, and this diesel could be used as fuel in jet planes. How can we take two abundant resources, water and carbon dioxide, and turn them into long-chain hydrocarbons, the building block for fuels like gasoline or diesel? This process could help us fight climate change by recycling carbon dioxide into something useful. Let's take a look at this. First, why bother? Hydrocarbons power our world. Think of jet fuel, gasoline, plastics and more. But burning fossil fuels, burning them in your car, produces carbon dioxide, and this causes global warming. What if we could reverse this? By using water and carbon dioxide and renewable energy, we can create synthetic fuels that are carbon neutral, meaning they don't add new carbon dioxide to the atmosphere. It's like closing the carbon loop. Today, we'll explore this chemistry and engineering behind this idea. Let's start with our raw materials. Water, or H2O, is everywhere. Oceans, rivers, even in the rain. We can split water using electrolysis. We can split it into hydrogen molecules and oxygen molecules. This is called electrolysis, and it can be powered by renewable energy sources like solar or wind. Next, carbon dioxide comes from the air, factory emissions, or even your breath. We can capture the carbon dioxide and use it as our carbon source. These two simple molecules, hydrogen and carbon dioxide, are the molecules we need to begin the process of producing synthetic fuel. Carbon dioxide is stable and doesn't react easily, so we need to activate it. One way is the reverse water-gas shift reaction. Here, carbon dioxide reacts with hydrogen, that's the hydrogen we got from the electrolysis in the previous slide, to produce carbon monoxide and water. Now this is carried out using a catalyst like copper or nickel and some heat of around 300 to 600 degrees Celsius. Now the carbon monoxide that's being produced is a lot more reactive than the carbon dioxide, making it a perfect stepping stone for building hydrocarbons. So the actual process that produces these hydrocarbons, or let's say the diesel or kerosene, is called the Fischer-Tropsch process. The Fischer-Tropsch process. In this process, it's catalysts that are unsung heroes here. They are the special molecules or reagents we use that don't get used up but make the reaction happen more easily. They speed up the reactions and can influence what is made. Short chain molecules like methane or long ones like diesel. Here we've made a hydrocarbon, but this is propane. So scientists can tweak the type of catalysts that they use here, like cobalt or zeolites, to give them the perfect recipe for fuels. Now what happened in the latest process is they have consistently been able to make long chains of hydrocarbons, that's 15 to 30 carbons in a chain, and that then can be used to make the kerosene that is used in aviation or in jet planes. This process, the Fischer-Tropsch process. All of these processes take energy. Now, in the current news article that I had said that they have been able to make these hydrocarbons with 70% efficiency. That means if out of the 100% energy they use to carry out the process, 70% of it is accessible from the hydrocarbons that are produced. Now, if we're going to make this from renewable energy, we have a few sources at our disposal. We can use something like a nuclear power plant that produces large volumes of reliable energy. We can use wind-powered turbines. We can use solar panels, maybe even hydroelectricity. We can use these renewable energies or this non-carbon dioxide creating energy as a source to carry out this process. So all of this isn't theory. Researchers at the Karlsruher Institut, in collaboration with partners from Sunfire and Climeworks in Germany, have successfully demonstrated an efficient approach to making these e-fuels. They have proven that they are able to make 100 litres of fuel a day, and they think that they can upscale this and process to make more fuel a day, and they'll test the fuel in aeroplanes to see if it works. This is a major milestone towards building a future where carbon neutral fuels power sectors like shipping and aviation. In their press release today, they said they are looking to produce a ton of synthetic kerosene a day. Now, this isn't enough to power all the aviation, but it does produce a model for what could be further upscaled to produce the energy that's needed without having to rely on crude oil or energy from the oil that is pumped from the ground. These synthetic fuels can, when they're made, just be dropped into the same engines that we would put in diesel in, or we would put kerosene in. There's no need to reinvent engines. It's a glimpse of a future where fuel comes from air and water. So, to wrap up, let's start with water, carbon dioxide, split the water for hydrogen, activate the carbon dioxide into carbon monoxide, and use this process, or the processes like the Fischer-Tropsch process, to build long-chain hydrocarbons. All of this is powered by renewable energy, by clever catalysts, and could turn carbon dioxide from being a problem into a resource. Challenges still remain, but the potential is huge. So what we can do now is we can have a loop, a sustainable loop, where the carbon dioxide that's released into the atmosphere is collected and reused again. So any carbon dioxide that we're adding to the atmosphere will be collected up and taken out of the atmosphere. A sustainable loop, we call it. This produces clean fuels, low emissions, and a sustainable planet. Thanks for watching. What do you think the future holds for this technology?